Hello friends, in this video we are going to discuss the disc mover and take it a little bit further than what we did when we were in class last week. So when we did the disc mover in class last week, you first did it by creating a program that was really just a series of drive forward, magnetize, drive back, demagnetize, and then repeat to go to the next one, and then to the next one, and then move over to the red column, and then move over to the green column. And that was fine. You met the objective, and that was all that you were required of. But this code is very long, and this code would be considered inefficient because it has way more lines of code than could be used to meet the objective. In programming, you like to use not necessarily the least amount of lines possible, but you would like to be more efficient with it. Another good reason to be efficient and use fewer lines of code is when you have to make changes, it's generally easier to only have to change a few things if you are doing things such as like repeat. So the second time we did the disc mover, you guys utilized controls. You did repeats because we're going up, then we're going down, and we're repeating similar algorithms. Today, we're going to go even more efficient. So I'm going to teach you a few new things to do the disc mover again using we're going to use variables and operators. And we're going to use a few more controls as well. So thanks, Finn, for letting me use yours. Let's now start a new block template. Okay. So the first thing I want to teach you is variables in coding. Now, you guys know what variables are. Variables in algebra are just a symbol of sort that references or represents a number. So when we did our last class, you told the robot how many millimeters to move each and every time. Now, instead of putting a number for how much we want our robot to move, we're going to establish a variable and then tell the robot to move that variable, which is defined in number. So here's what I mean by that. Let's go to variables. The first thing we're going to do is we're going to make a variable. And let's call this variable distance. And instead of typing in a distance that our robot will move, we're going to tell our robot to move distance. So the next thing you have to do is establish what you want your initial distance to be set to. And if you remember, when you do this robot, each grid is 200 millimeters. And the first movement is going to be 200, 400, 600, 800. So I'm going to have my initial distance be 800, because then it'll stop right here, and then I can pick that first one up. So I'm going to set my distance to 800. And then just to make my code move faster, I always like to just set my drive velocity and turn velocity to 100 each, so I don't have to wait as long in between movements. Okay, so if you look at the playground, and I guess we'll start by trying to do the first color, which is blue. So when we go blue, let's talk through what we actually want to do. We want our robot to travel not 800 millimeters. We want our robot to travel distance. Then we want our robot to magnetize. Then we want our robot to reverse distance and then demagnetize. Then we want our robot to move forward distance plus 200, 400. So distance plus 400. And then reverse distance plus 400. Then we want our robot to move forward distance plus 800 and then reverse the same. So let's talk about how we're going to do that. So we're going to do that by adding a repeat function. And we have three discs that we want to do. So we're going to have this repeat 3. And we're going to have our robot drive forward. And the default is for 200 millimeters, but I don't want to have my robot drive a distance. I want my robot to, let me rephrase that. I don't want my robot to drive a numerical value. I want my robot to drive my established variable. So I want my robot to drive distance. So I'm going to swap this 200 right here for distance. And now, because I've established that distance is 800, this robot will drive forward for 800. And once it drives forward for 800, I want it to magnetize next. So I'm going to do boost or energize magnet to boost. Then I want it to drive reverse for distance again. And then it drives forward for 800, reverse for 800, and then I want it to demagnetize. So magnetize to drop. Great. But now, if you leave it alone, let's see what happens. It drives forward for distance, picks it up, drives back, drops it. It keeps going distance, which is 800. But what we really want is every single time it goes through this algorithm, before it repeats, we actually want to redefine what distance is. So we want distance to increase by 400 each time. So at the end of this block right here, let's go back to variables and let's set distance to what? To 400? No, that wouldn't help. To distance? No, that's not going to help either. We actually have to do an operator. And an operator is just a mathematical equation that you'll have your value. So it's green. What we really want our distance to be after we do this one time is next time we want it to be distance. Oh, why did that not work? Distance plus 400. So after it does it one time, the second time, distance will be redefined to be 800 plus 400, so 1200. And then the third time, it'll actually be 1600, and it'll pick it up every time. So now let's go ahead and try that again. Voila. Okay. Now we want our robot to do the same thing for the next two columns, for the red and for the green. So I'm not going to help you the rest of the way. This is where you're going to have to do this yourself, but I'll help you get started initially. So you're going to do control. And well, now that we've already done one column, we have two more columns to do. So it's going to start with a repeat. Whatever we do, we're going to want to repeat 2 more times. And let's just talk through logically what we want to accomplish. And then you can add the programming after. Let me actually go ahead and complete that again. Now the program ends with all the blue discs in the blue box. So what we want to do is we want our robot to move right, move forward, move left, and then do that sequence again. Then once he's done, we want him to turn right, move forward, turn left, and then repeat that process again. So I'll give you a hint. You will actually have to do a repeat and then some drivetrains over here, and then you'll actually need another repeat embedded in the previous one. So this isn't exactly what it'll look like, but it'll be something similar to like repeat blah blah blah, and then a repeat embedded within a repeat. So that'll be my hint for you. Okay, so your assignment is on Google Classroom. You will see a Vex VR file that I've created, which basically gives you this starting point. And you are going to open that, rename it as I tell you, and then try to finish the disc mover while using what we know about distances. One other hint I'll give you is distance right now is going to be defined at 1600. That's where you left off. So you probably are going to need to throw another set distance to have it be back to where you would want it to be when you begin the next color. Okay. You guys can email me questions. That's fine. We can also set up time for an office hour of sorts during class time if you are really lost and need assistance. Okay, that should be it for now.